Hello everyone, my name is Jacob Villagomez, and in this presentation for CSET4850 for the University of Toledo, I'm going to be going over the fundamentals of web security. So web security, what's it all about? So web security is a broad topic that covers protecting computer systems, the network infrastructure, and devices from cyber attacks, theft, phishing, and malware, no matter if it takes place either on the client side for like the general user, or the network side for the companies. They're both susceptible to attacks and vulnerabilities, which can be from SQL injections, cross-site scripting, weak passwords, viruses, weak security policies, and more. So the types of web application attack methods, so according to OWASP's Top 10 for 2021 list, also known as the Open Web Application Security Project, they're an independent research organization that researches many methods on cybersecurity. The top three most common attack methods used on web applications are broken access control, second is cryptographic failures, and the third most popular are many types of injections, which I'll go over right here. So broken access control, it allows unauthorized users to gain access to sensitive data and resources. So an example on this is that an attacker can exploit this by manipulating the URL or HTTP parameters of a web application that bypasses authentication to gain access to those resources. So how do you prevent broken access control from attackers? Web administrators are best to perform the following methods according to OWASP, which are to deny private resources and keep the public resources available. Second, they must implement and model access control methods. Third, they should disable web server directory listings from the general public. And fourth is to log access control failures and report them to any IT or information security personnel. Second most popular method is cryptographic failures. So cryptographic failures, also known as sensitive data exposure, is it highlights the lack of security measures that causes sensitive data to be leaked. Two examples on this. One of them is that a website not using HTTPS allows sensitive data like credit card numbers, emails, or passwords to be intercepted by an attacker. The second example is that using a weak cryptographic algorithm or algorithms or protocols can increase the chances of data being exposed. So how do you prevent cryptographic failures? The minimum safety methods that web administrators must do are to encrypt all sensitive data and classify any data that's being processed according to certain privacy laws, such as the European Union's GDPR, California's CCPA, Canada's Digital Charter Implementation Act, and other similar laws throughout many states and countries that do have privacy laws in place. Second, they should not store sensitive data that could be easily accessed by unauthorized users, whether if it's inside the corporation or outside on the general web. Next, they should keep cryptographic algorithms and code up to date and disable caching that contains sensitive data. And injections. This broad term can cover many types of web application injections, such as SQL injections, cross-site scripting, and external control of file name or path. So SQL injections. A SQL injection allows the attacker to type in SQL statements into a field of text, usually a login prompt or a password, to attempt to modify, delete, or access database information to which a normal user does not have access to. An example of this would be that an attacker types in the following into a username and password input field, the is quotation mark or quotation mark, another quotation mark with an equal sign and another quotation mark. This comes up as a SQL statement. Select from users where username equals quotation mark or quotation mark equal sign quotation mark and password equals quotation mark or quotation mark equals quotation mark. It will return all rows of usernames and passwords because the or quotation mark equals quotation mark statement is always true. Next is cross-site scripting, also known as XSS for short. It allows the attacker to attach malicious code or script to a website in which will execute when a client loads the website. It contains a JavaScript code where the attacker can insert the executable code using the script tags, as it allows the attack method to be used to steal like a user's cookies, to impersonate a user for social engineering attacks, or accessing sensitive data. An attacker can also use HTML to perform cross-site scripting, other than JavaScript or including PHP. They could also use PHP, JavaScript, or HTML to perform this attack method. Add external control of file name or path. According to the Common Weakness Enumeration, the CWE, it's defined as an attacker that allows user input to control or influence paths or file names that are used in file system operations. An attacker could use this method to access or modify the system or other similar important files that are critical to the application. And how do you prevent general injections? To prevent injections from an attacker in web applications, the administrators must do the following, which are to implement a safe API that avoids the interpreter entirely. Second, they should use the limit SQL control method to limit certain SQL commands, like if they were to perform SQL injections or other similar injection attack, and also to use positive server-side input validation. And malicious logic, going on to another topic, malicious logic, just a general definition of what it is. So malicious logic is an application or a set of code that performs an adverse effect on a computer system or network infrastructure. Web security also covers the many types of malicious logic that attackers could use, ranging from viruses, which I'll show you in the next slide, the many types of different viruses, computer worms, grayware, rootkits, and many more. So the types of viruses, there are several types of viruses that your typical computer virus. Those are, so on the left-hand side of your screen, we got the boot sector infector, the executable infector, multi-party virus, and a TSR, also known as a terminate and stay resident. So a boot sector infector, it inserts itself into a boot sector on a disk, whether it could be like a hard disk drive, solid state drive, a floppy disk, CD, optical disk, or some similar disk that can be loaded into a computer system. Second is an executable infector, which only infects programs, executable programs to be specific, that ends in .exe or .com. The third one, multi-party virus, as it could either behave as a boot sector infector or an executable infector. If this type of virus behaves as a boot sector infector, then it'll be simply a boot sector infector. Or it could be an executable infector, where on the other hand, like I've mentioned, it can behave like an executable infector and will be like one. And fourth one, TSR, it stays active in its memory after the application terminates for this type of virus. On the right-hand side, we got the stealth virus, an encrypted virus, polymorphic virus, and a macro virus. A stealth virus, the fifth one, it tries to conceal the infectious files as much as possible once it infects a computer system or a directory. The sixth one, the encrypted virus, it encrypts the virus code like all of the virus code except for a small decryption routine. Then we got the polymorphic virus, as it changes its form each time it inserts itself into another program. And finally, a macro virus, which is a sequence of instructions that are interpreted rather than executed. Now we go over to a computer worm. So a computer worm, it replicates itself from one computer to another without pretty much any human interaction after it's been executed. A worm generally spreads like on an email server. We use the SMTP port by sending emails with the malicious attachment to other users in a network. The worm just copies and pastes like different emails in the SMTP server of a network infrastructure and sends that malicious attachment. And if that user were to load the malicious attachment to their computer, then their computer could be infected from there. This could cause damage within the network as it, 1, increases bandwidth, 2, and it also slows down internet speeds. It can also harm computers as some worms can corrupt or delete important data. And grayware, the third one. So grayware, also known as potentially unwanted programs, or PUPs for short. They are applications that install additional programs without the user's knowledge. This can be dangerous as some PUPs could contain malicious code that could damage their computer. This is generally common if a user were to download and install a program from an untrusted source on the internet, where it installs the program normally as so, but could install other programs in the background with or without the user's prior knowledge or consent. And a rootkit. So a rootkit is a collection of software that allows someone to mask themselves online to gain unauthorized access to a device. This makes it difficult to detect such a rootkit and to remove it because it could be well hidden in the system while it's active. A keylogger. So a keylogger is a malicious piece of software that tracks a user's keystrokes without their knowledge. This could be used to figure out someone's passwords or usernames by studying their keystrokes. It could be either a program that tracks the user's keystrokes, or a USB or a PS2 device, one of those old PS2 optical ports that is plugged in to a computer. And here we got an info stealer. So an info stealer is a type of malware that collects like the general keystrokes, computer data, browser cookies, session tokens of a web browser, and other valuable information from the user. And just recently, about a month ago, on March 23rd, 2023, a popular tech-oriented YouTube channel called Linus Tech Tips, who's got over 15 million subscribers as of me speaking right now, had their account hacked when an employee accidentally downloaded an info stealer from a fake sponsorship email. So what I got here with this example of an info stealer, I got these two photos listed right here. On the left, just looking over my notes here, what I got loaded is a hex editor called HXD, It's a hex editor where I got a malicious program, an info stealer, that I downloaded from a typo squatted website called OBS ProICET, PROICET.net, instead of OBS Project's real website, the software, the recording software, obsproject.com. So a typographic website, a typo squatted website, is basically, it tries to trick the user into thinking like they've typed in the real website when it's actually not, even though it looks like the real one. So the program I downloaded from the typo squatted website is called OBS Studio 29.0 Full Installer x64.rar, which a RAR archive contains a single file called OBS 29.0 manual.pdf.scr, which that fake pdf.scr, that's what Linus Tech Tip employee had downloaded, which caused the account to be hacked and terminated by YouTube, but his account got reinstated by YouTube. In this case here, the fake pdf.scr file, it uses the PDF icon to disguise itself as a genuine PDF, but the .scr extension is actually a screensaver file. And with the file loaded up here on the hex editor, as you see here, I got many of the machine code, as you can see on the top here, and below it, where it says like the 0s, 30, 30, 30s right here, is that it's trying to inflate as much storage as much as possible, because this file, before deleting any of the fake hex files or hex values, is that it initially had a file size of 314 megabytes. The reason why it has a large file size is because it's trying to bypass any antivirus scans, because it doesn't want to waste too much of its valuable resources to scan that one file, whether if it's from downloading from the internet, doing a quick scan or a custom scan or whatever. You have to do a full scan to quarantine the file and delete it from there. And on the right side of your screen here is after deleting many of the fake and inflated hex values, going from 314 megabytes down to 15-ish megabytes, is that I got a website called virustotal.com, and I uploaded the file to the website, and most of them contains, I think, like 16 out of 66 like red flags came up from many different security vendors and their antivirus scan engines, and most of them came up as a Trojan horse file. Next, we're going to be going over is social engineering. So real briefly on this one. So social engineering is a practice of manipulating a user into giving personal and financial information to an attacker to commit acts of fraud and identity theft. This practice is known as phishing, which I'll explain here. So for an example of phishing, if someone were to receive an email from Netflix stating that their billing information needs to be updated for whatever reason, they include a hyperlink to fill out their login and payment information to the fake website. If a user were to fill out the fake form, that information will be sent to the attacker who could see the submitted data in real time. If successful, if they try to get everything from like their login information and banking information to the attackers, they could use whatever info they got from them to make fraudulent purchases with the victim's personal information. And an example of an attempted phishing attempt, this actually happened to me back in, I think, 2019, where I had a phishing email from a fake job author from the university that somehow and someone created a real email using the university's credentials, and they were offering me like a free job or whatever for like $400, $500 a month, work from home or something like that. So I only filled out my name, email, and address, where they sent me this letter. As you can see the top portion of your screen, it came from the sender. The sender's name is called Petco Store, based in Kent, Washington. And when I got the letter, they sent me a text message saying that, hey, first you need to send money to us and then cash the check to those guys, to my bank account. Which right in the bottom right here, the check down here from the breakers of Edgewater Beach, the attackers were sending me of an amount of $1,950, meaning I was going to cash a check for $1,950 to get me started on their work and to take out some of the money and give back to the attackers for my banking info. And also about the check where it came from, the Breakers of Edgewater Beach, the actual name of the company based in Chicago, Illinois, which is a senior living facility, is actually called the Breakers at Edgewater Beach, not the Breakers of Edgewater Beach. So in conclusion about web security, so web security plays an important role on the internet. No matter if it takes place on the client side or the network side, as there are numerous attack methods and vulnerabilities people must combat to ensure everyone's data is safe. Web administrators should consider making changes to their security policies, such as implementing an intrusion detection system, strengthening their firewall policies, and making changes to their programs and databases safe from attackers trying to gain unauthorized access. Users should also be aware of any suspicious programs and emails they come across so their data is not compromised. And as attackers are diligently finding new ways to intrude on someone's network or to steal information and take down websites, that is why companies are taking a stand to make sure no one outside their organization tries to tamper with their web applications and sensitive information. And right here are my references that I used throughout this entire report and presentation. And that is it for this presentation on web security. Are there any questions, comments, or concerns in regarding this presentation?